local to San Francisco? Nice. Awesome. Well, welcome. Thank you for being here this evening. Like I said, as many of you are probably busting around JPM this week, and just really glad to see so many of you here. As someone who's been in the industry and in neuroscience for the last 10 years, it's really cool to see the level of enthusiasm that we have for the field nowadays. So yeah, welcome. Like I said earlier tonight, the purpose is to not really pitch or lecture or even inform. The purpose of tonight is to just have a space to converse. I'm lucky to be here with one of my really good friends who's also a neuroscience researcher and founder. And hopefully this will be the first of many conversations. Before we get started though, I want to give a quick shout out to Morgan here. He is the executive director of Neurotech X, as well as the floor lead of the Neurotech and Biotech floor here in Frontier Tower, which is also our wonderful office and home base, but also host for tonight. So I'll just give it to Morgan to say a few words on.
Thank you. Yeah, just welcome to Frontier Tower, vertical village for frontier technology here in the heart of San Francisco. If you have questions about Neurotech X, we're a nonprofit. We're in most major capital cities, as well as we have student groups, wonderful student groups in lots of universities, North America and Europe. And would love to talk about what we're doing on the 8th floor. I'm also with Biopunk Lab, so a founding member of Biopunk Lab. We run the wet lab on the 8th floor. So we're not just doing non-invasive neurotech, but we have cell culture facilities and other facilities for developing all sorts of wonderful technologies. I thought I saw James here. Anyway, yeah, James, we can also talk about the 3D bioprinting and other work that we're doing on neuronal culture that is really innovative. And yeah, welcome to JPM Week, and I will turn things over.
Thanks, Morgan. And if anybody has questions on Neurotech X or Frontier, he's the guy for you after the event. So before I introduce Avery more formally, I just wanted to tell you a little bit about myself because many of you don't know me. My name is Giali. I am the founder and CEO of Soma. We're also a neurotech company based here in San Francisco. Our mission is to make brain health more accessible, so we're consumer neurotech. We're building really the world's first software brain-computer interface, still in stealth, but have a lot of really exciting announcements this year. So if you visit our website, you can join our waitlist to be a very early user of our product, and also join the bigger movement to take care of our minds as we do with our bodies. At that, I am really excited to introduce our special guest tonight, Avery Krieger. Avery is the founder of Constellation Labs. He graduated his PhD in neuroscience from Stanford University, and tonight I will really just be talking to him like I'm talking to him normally as a friend, and hopefully you guys can join in towards the end too with questions and discussions. So yeah, we'll get started. Hi everybody.
Hi Giali.
This is a very surreal moment for Avery and I both. I can speak for a little bit for myself because we met nearly 8 months ago now, and the first time that we met was on a walk in Golden State Park, and Avery was telling me about his neuroscience research. We were bonding over finishing our PhDs and starting to think about building companies in neurotechnology. And once in a while, he'll stop and point out a random bird or like a random camera, because he is a landscape photographer as well as a neuroscientist. And fast forward 8 months later, we're both building and doing the thing. And yeah, how do you feel, Avery? How do you feel about this moment?
When I try to reflect on this experience to friends and family and other neuroscientists who I worked with and other grad student friends of mine from Stanford, I think this is probably the first time in my life I felt like three things all at the same time. It's like I'm really good at something, like I find the thing valuable and fulfilling, and that like I'm well compensated for it, and the competition isn't just like the money, it's also just like people appreciating and validating and having value for the work that you're doing. So extremely fulfilled and happy. It's amazing and inspiring because I get to have peers that.
Yes, that's one of the coolest parts about this whole journey is building alongside friends. So just to kind of set the stage and bring everybody back a little bit, tell me about your first encounter with the brain. What led you to neuroscience? What were the questions that you had that you wanted to answer?
Okay, I'm gonna be genuine and honest. I'll tell everyone here there's two versions of this story. There's a version that I would like tell in like an application to something, pitching or whatever, and there's like the real truth, and it's I'm down. You guys seem like a safe space crowd. So the thing that originally got me, I guess like caring about the brain was that my grandmother got in a really traumatic accident when I was very young. And I witnessed this accident, and it left her in what the doctors said was a vegetative state or a coma. And I think what was really hard, I was very young, so it was very hard for me at the time, is that everybody, including my family, like, that was the narrative, was that she like, wasn't really there, that she's in this state. But I had spent my entire life up to that point being, my family were animal rehabilitators and trainers and breeders, and so I had done this like inference game from a young age of like trying to intuit what was happening inside of like the mind of an animal, this nonverbal communication piece, this sort of like, you can't like get an animal to be rehabilitated if you don't have a good estimation of like its capacity to trust, you know, it's like it's part of the game. And so I'm sitting there, young me, and I'm like hearing everyone talk about how my grandmother's not really there, and it's just like not the vibe that I have in this situation. I'm like, it doesn't seem like that's correct. It doesn't seem like she's not really there. And when my family eventually took her off of life support because it was really expensive and complicated, I was devastated. Like I couldn't reconcile that experience with what everyone was saying. And you know, it's not like my superhero origin story of being like, I must cure this thing, but it was very much like the beginning of a really long session of understanding, like how did this happen, like was I right, you know? I always kind of believed I was right, and it didn't take long for me to learn, for example, that it's extremely common to misdiagnose people who are locked in, being in a coma, and I just like, I can't express, like, to me it's like one of the most existentially horrific things, like imagining you're sitting there and you're paralyzed and you can like watch your family decide to kill you. It's too much. So I went on to study first psychology because I thought that was the thing, and then cognitive science, and then ultimately neurobiology and systems neuroscience because I wanted to understand. Now my first personal interaction with the brain was coming in that transition from cognitive science in college. I did a little bit of research in the primate lab where they basically put primates in like roller coaster simulators to like try to understand how their vestibular systems and their visual systems integrated. And anybody who's ever done like a neuroscience 101 class has like seen like action potentials moving. They'll hook up like a speaker so you can like hear the firing of a neuron. And I remember the first time that I like dropped an electrode into this primate, showed it some stuff on a screen and like moved around the stimulus and saw the neurons firing and heard them firing, and that was when I knew that was the right field for me. It was going to have to be neuroscience.
What do you think was the most kind of puzzling thing that, as a little kid, young Avery, watching your loved one suffer and then kind of catalyzing this, maybe not even like intrigue, but just questions about the brain? What do you think was the most puzzling part? And throughout your research journey, how do you think you kind of went back to that?
My thesis in general, I think is very unifying across a lot of different disciplines and belief structures and science fields, is that like we're all just like as animals, but as humans specifically, just trying to control our states. Like we just want to be in a state, and maybe that state is like a state of happiness or a state of avoiding depression, or it's a motivated state. Maybe the state's like to be asleep, or maybe it's to be awake. And we do all these things. We like meditate, and we take drugs, and we go to therapy, and we exercise, but it's just to like move our states around. And I guess I've always just it's always just been confusing to me, and it's puzzling to the extent that I've tried to study it for the last 15 years, like why we don't all just think about it that way, because things would get a lot simpler if we all did. And also, like, if you put everything in this like state space, if that was the problem that we were all trying to understand and solve, then like everything kind of starts to make sense from like a therapeutic perspective, from an intervention perspective in general, from a research perspective. And it was in college that I first got exposed to Tom Insol's RDOT criteria, which was basically like an idea of like researchers trying to do something other than just like use the DSM. If you don't know what the DSM is, it's one of the many weird ways that we like historically cluster people's brains and psychologies for the purposes of like giving them drugs and getting insurance money, which like has nothing to do with like how biology works. And so there was this movement, now like 20 years ago, to try to stop thinking about it in this like weird way and start putting people in these like big state space maps. And I'm like, this is exactly what I'm talking about. And I got really excited. So I think that was a pretty big pivotal moment for me. And just understanding that other people, I wasn't the only person in the world who had this idea, and that people have been trying to impose this logic on structures for a long time.
For folks who maybe don't have the neuroscience background or context, can you describe what you mean by a state?
Yeah, I don't mean anything specific, which is why I have to use this word. It's like the most overloaded, worthless term. Okay, like a physiological state would be like your hunger or your thirst or your other kind of thirst, or like how tired you are. Those are all like, that's a physiological state. That's like if you don't have enough food, then you go into a state that is primarily defined by like looking for food. Like your behavior changes, physiology changes, like the way that your gastric emptying relates to this. Like your whole body and brain reorient around that state. Everyone knows what it's like to be in a state of being unconscious because you've all gone to sleep. Those are like states that are physiological. And then there's other kinds of states. There's cognitive states, like how focused you are, like where your attention is. There's emotional states like mood and just generalized emotions. I mean states in a really broad sense because I'm trying to like include it all, because I think all of those states do matter.
So this brings us a little bit towards kind of what you're building today at Constellation. You're building foundation models across different states of the brain, the body, and the environment. So tell me in your words, what is the interplay between these three things? And why is it important to consider all three, and what sorts of insights are you trying to glean?
Yeah. So, we call it neuroscience, but which like refers to the neurons, those like cells in your brain and your spinal cord. But also you've got neurons all over the rest of your body. You've got a ridiculous amount of neurons in your gut. You have somatosensory and proprioceptive, like little sensors in all of your muscles and all over your skin and inside some of your organs. And you have motor neurons that control movement and all different aspects. And then there's this whole other group of cells that support them and maybe do their own computations called glia. There's this really complex biology, basically, that isn't just like the things happening like between your ears and your brain. Like your nervous system is doing a lot, and it interplays with your immune system and with a lot of other, basically every other body system. And so first pass, it's like sort of, you have to think about embodied like neuroscience. You can't just think about like a disembodied brain and spinal cord in a jar. Like your brain is inside and integrated in the rest of your body. Like anything that happens to your body, your brain is processing and telling you. So that's kind of the physiological body part you have to bring in. That they're intimately related. And then I think like you can kind of imagine using the environment as sort of like cheating, right? Like if I want to understand what's happening inside of a brain, it's like pretty hard. I would argue it is the hardest problem humanity has ever tried to address. It's like understanding what's happening inside of people's brains. But like, it's not as hard if you cheat a little bit. It's like, well, I don't think that like what's happening in your brain and body right now, if your heart rate is elevated and you've got this cortisol spike, is because you're like skydiving or exercising, because I can look at you and I know that you're sitting in this chair. And so the environment actually just gave me a big hack. It's like, maybe this response is more contextually related to like, stage fright. Not saying I'm the one with the stage fright.
You guys are giving me a cortisol spike.
But it's like all of those pieces sort of like help make this problem more tractable and easier. And ultimately what we want to do is we want to have really good models that we can then leverage them to help people and have people help themselves. And so we're just taking everything we can get. We're taking the environment, we take the body, and we take the brain.
How do you think about when you're trying to kind of like narrow in or focus on the states of one dimension of this? How do you think about the different confounding factors and how you parse through them?
It's like the hardest problem. It's like the hardest part. There's like two schools of research, I guess, broadly that can address this question. Most scientists do a type of research where you basically control everything that you think you should and can. You're in a lab, the temperature is a specific temperature, the lights are a specific kind of light, the person doing it is following a really precise protocol. You make sure that everything weird that's going on, you control all of it. And that way, the only thing that changes should be a result of like the thing that you do. That's like a real classic way of doing science. And then another way of doing science is say, well, that's weird, and everything you get there is sort of like contrived and doesn't generalize out of that environment. And so you could do something different. You could make it more naturalistic. You could sort of like have things be as they normally are. And the reason why nobody does naturalistic things is because it's basically impossible to know what's going on. There's like too much happening. It's too much uncontrolled stuff. But we're entering into an era, I think, where we're increasingly able to handle the complexity of those natural signals. And I think our biggest challenge of probably this generation of engineering and science is to better leverage all these computational tools like large transformer models to start handling this disparate kind of data, these disparate kinds of contexts, to then sort of like cut through the noise a little bit and get some of that relevant signal.
What do you think is, we talk a lot about the technical challenges, what do you think is the biggest non-technical challenge in a world where we can attach things to people and environments and capture all of the different sensory stimuli and data? What do you think would be the biggest hurdle there?
Do you watch reality TV?
Sometimes.
So, just raise your hand if you ever watched an episode of reality TV from start to finish. Okay, cool. I like thinking about reality TV for a lot of reasons, but reality TV is kind of cool because it's horrific and cool for the same reason, which is that it's like a fully constructed environment, right? Like the reality part of reality TV is a trick. It's designed to make it entertaining on some axis. And so if you think about like a dating show or whatever, where like it's like The Bachelor, they like get everybody just drunk enough to be like a little bit emotionally unstable, and there's like a guy whose job is like watching everyone's drinks and then giving them more alcohol so they can push people over like a certain kind of state edge or something. And I think like the hardest part of any naturalistic or controlled environment is that it's like people that you're dealing with. So I could tell you as a participant in a research study, like, please do this thing. Like, I'd really like you to like do this thing. Please, give you money, research credit, and like just please do the thing. And you could just fall asleep. Like you just not care about me asking you to do that thing. Or you could just pretend to do the thing and then do something really weird and complex as like to spite me or something. Like, or you could just be confused, or I could have explained it wrong. And I think that like there's just this innate just weirdness of being a human that manifests in so many funny ways. My like one story that I will like never forget, it really burns into my brain, is in undergrad I did these like, the field is called psychophysics. It's a field where the whole point is you can, like I talked about, control. In psychophysics you control everything from the perspective of like a person. So it's intense. You have to like really go hard at making sure the environment is really precise, and then you have to give people really precise instructions, and because all you're doing is recording their behavior, and you want to make sure that you're recording anything. So I do these just horrific experiments. Nobody likes to do them. You like sit in a weird chair with your like head fixed to something, and you're like staring at gradients and like pushing a button. It's vaguely dystopian. And so I'd have people do this experiment, and one day I realized that like the way that we were reading the instructions was like just a little bit weird, and I was like, oh, I think I should make this change. And I go and talk to my boss, and I'm like, hey, can I make this change? And he was like, oh God, no, don't make a change in the instructions. And I was like, it's like I'm saying if instead of like this other thing that is basically if or something like that. And he was like, no, we tried that in the 90s. Like we once switched to if, and it just blew out all the signal in the experiments. And I was like, there's no way that you have done this exact thing before, and it was that big of a deal. I mean, he like pulled it out, he like had it in his desk, and we looked at it, and it was like 10 times the effect size was because of like a single word change in the instructions that should have been inconsequential. And it's stuff like that I think it just, people are real messy. It's a really hard problem. I think we're going to constantly deal with that.
Do you think part of it is also like a cultural thing?
I mean, I think I think everything is a cultural thing. I think
True.
the way that people communicate is like one of the bottlenecks of doing like human subject participation, and communication is super cultural. I mean, even the way that we feel things is cultural. So I think, yeah, there's a lot of cultural elements.
Yeah, I love thinking about the interplay of culture and science. I think people often separate the two because one is so logical and one often isn't logical. But like you said, I think that the states and the different dimensions of the states are often intertwined. Going back to, you briefly mentioned, you know, kind of this period of studying and really like digging and asking questions. You studied under some very renowned neuroscientists of our age, Krishna Shenoy being one of them. What do you think is the most important thing that you learned from them, and how does that shape how you're building Constellation today?
Yeah, so I came to California like more than 10 years ago to work with Krishna. I kind of alluded before to being obsessed with this understanding of people being locked in, not being able to communicate or move, and Krishna at the time was running the best brain-computer interface lab in the world. That lab went on to become Neuralink and all the other companies that you know of. So I went to work with him because I just thought it was my best chance at solving this problem and understanding it. And what I didn't know is that Krishna had a really big life event happen maybe 7 years prior, where he had gotten like a terminal cancer diagnosis, and he had like there was no way he was going to survive. And then he had a bunch of like experimental surgeries and got really lucky and like made this bizarre, miraculous recovery. There's like books written about him, but he was basically went from like I'm going to die to like not dying and then going into remission. And I kind of came in like late into his remission. And what was kind of interesting is that when I got to the lab, everybody kind of treated it like a family dynamic, and I hadn't really experienced that before. Everyone was really close, and I had like later learned that that was sort of a transition that happened after he had his big like, cancer scare. And I think one of the many things I learned from him in that environment that's sort of carried forward is like not really a science thing. I could talk about Christian science contributions all day. I'll say one before I move on just because it's important. But like the thing that really got me was that you can do something as intense as that work, and you can treat it like a community effort, like a team effort, where we're all like trying to solve this together, and nobody looks like an idiot if you don't know the answer to a question, because we're all trying to figure it out. And that wasn't like all the environments I've ever been in, and yet it was still like really extremely rigorous. It's still one of the best labs in the world, if not the best. So I think ultimately, from Krishna, I learned that you could have these really intense environments that didn't have to be intense on the axis of like people feeling uncomfortable to, be wrong or ask for our help. So that's one thing. And the other thing I'll say is like Krishna's sort of like one of his claims to fame was that he brought electrical engineering into neuroscience, which signal processing as like a discipline that happened because in world wars it was really useful to like shoot bombs out of the sky. That went on to become like one of the most fundamental aspects of like what we think of as modern neuroscience, and it was people like Krishna who like looked at the problem of the brain, looked at the problems that they'd been trained for in electrical engineering, and were like, well, these are kind of the same problem. We could probably help out by being rigorous here. And that just, all he did was take one discipline and apply it to another, and it changed the world forever. And I think like that, he was very brilliant, but that wasn't like some great insight. He just took what he knew and he took it to a new space. And I think there's a lot to learn from that.
I love the first thing that you said, because I feel like oftentimes when I was in academia too, when you encounter some of the greats like Krishna, it's very sobering to see the very human side of them, and then it's even better to see them lead in such an inspiring way. And I think as a student, you're still imprinting in many ways, even though we were like prefrontal cortex has developed at that point. You're still imprinting off of these people, and I think for myself too, having studied under some really awesome supervisors, it's really shaped how I think about team building today. And so, we're both building in a very, very, very fast-moving industry. Neurotech has kind of blew up over the last few years. Today, Merge just announced their massive fundraise, and their whole mission is to merge biological intelligence with artificial intelligence. And there's all these humongous goals that seem still quite far away, but also a lot closer than ever before. how do you yourself stay grounded amidst all of these, massive changes, and how do you also help your team stay grounded?
Yeah. Well, there's a couple ways I could answer that. It's a good question. I should have thought about this before. Our team stays grounded in like a really obvious way, which is that we get together at least once a day, and we have these interactions that are sort of like non-separatives from the work. I think there's a startup culture in San Francisco and Bay maybe that's like you kind of live in the office and your whole life like centers around your work, and like anything other than that is bad, and like whatever. I'm sure lots of companies are successful doing that, but I personally just like don't love anything enough to only have it be one axis. Like my whole personality revolves around that axis, so I like have a bunch of weird music making devices in the office, and like we cook together, and we just like do like normal people stuff like throughout the day. And I think that's pretty critical, like for me especially. Like maybe they're all just performing for me, but like I actually it is like requisite for me to be able to engage. And then we touch grass. I don't know. We like go outside sometimes. It's nice.
Easier to touch grass in the city, luckily.
Yeah.
Okay, last question before we move to a rapid fire, and then I'll open it up to the audience as well. What is a belief that you had building in Neurotech that you've since had to unlearn?
I think everybody is like poisoned, and that's a strong word, but I'm trying to make myself feel a little bit hot take here tonight, by like the conceptualization of Neuralink. Like when people think of neurotech, they think about Neuralink. That's so laughing, I just talked with her about this. And I think everyone has the same image in their heads of what it means to do neurotech. And we, in Krishna's lab, it's now like it's kind of a common saying, but we're kind of weirdly common given that I feel like we made it up in Krishna's lab. We were talking about like the best BCI is like a phone. Like that's the best brain-computer interface. It's like extremely good at taking what you want to do and like enacting it on the world as an interface. And that's like how do you get better than that? And it's like, what are we doing with these like invasive devices? But the reason why I say Neuralink is sort of poison the image is because it's like there's so many ways to write signal into brains and to read signal out of brains that doesn't involve opening up the skull. And I think it's not that I didn't know that, it's that I didn't appreciate how hard it was to like re-communicate that to the rest of, to investors, to lay people, to my family, to people who are hiring, like that, because they have this idea of Neuralink so firmly like embedded in their minds. And so I think that's always been like I'm grateful to Neuralink for existing because it got so many more people excited about the space. But it is kind of funny, it's like you're talking to somebody and it's like they think that, if I flash lights at all of you at a certain frequency, you like get nauseous. Like, is that a neurotech device? And it's like, I mean, kind of. It didn't involve me opening up your head. So I think I just say this because, huh? Oh. I will happily slow it down for you. I'll just say it again because I think it is kind of interesting. Like, we actually do have so many ways that signals can go straight from our periphery, like our eyes or our skin or our muscles, straight into our brains. And I think being really creative about how you get signals into a brain or how you read them out from like the way that you move or the way that you talk, like that we have this bidirectional BCI that's just like our behavior and our sensory apparatus. I think we should take more advantage of that.
I love that point. I think what we're building at So Much You, we very much identify with that, I would say, thesis that, neurotechnology doesn't have to be a tiny little implant that you can't see that goes directly on your brain. Everything that we do from the ability to, walk and eat and digest and sleep and speak, it's all literally from the brain. The brain is controlling all of this, modulating all of this, enabling all of this, and in many ways our behavior is a brain signal. And so when you think about it from that point of view, it's very much, our phones could be a neurotech device because it's the recipient of our behavior. And I definitely kind of identify or sympathize with the unlearning of that myself, but also trying to help others unlearn that kind of concept of neurotechnology, especially in this day and age where, you know, the Neuralinks of the world are very impactful in many ways, and they've done a lot of great things in bringing forth the field. But I do think it's a really, really important point to remember that brain signal doesn't just come from the neurons themselves. It's very much projected outwards from there. Okay, so with that, I'm going to end with a few rapid fires, and then we'll open it up to the audience. I'm going to start with a very personal one.
What's brain binding environment? What is that? What does that mean?
It is,
My name is Jeremy, I'm American European citizen, I'm American.
okay. What was little Avery like, and what would you think of the Avery today?
Little Avery was difficult. I like to ask difficult questions, but couldn't articulate them well because I was little Avery, and so it was just me being annoying and trying to solve my own problems through continuously questioning people. I think at the end of the day, though, like little me's like primary goal was just like to explore and to like find fun and beauty in the world, and I don't think that's changed. It's just like too many years of science have made me ask harder questions, I think, that suck a little bit of the fun out of the room sometimes when you're trying to understand something. Yeah, I think this has kind of been my life's work, to ask these questions and try to answer these problems or address these problems. So I think Little Avery would be proud.
Love it. Favorite brain region and why?
Wow. Favorite brain region. I'm gonna be lame and say like there's a really weird unknown part of the brain for most people where like the very top middle of your brain in like one of the deep grooves there's a all the proprioceptive information. It's okay. You close your eyes. I'm making everyone do this. Close your eyes, all of you. Take your index finger and touch it to your nose with your eyes closed. Wow, that's it. Okay, you can open your eyes. You can do that because your brain knows where your body is in space at all times, which is like, if you think about it, like go think about it after this. It's kind of a weird thing. And the way that your brain knows where your body is there's like tons of little embedded sensors in all your muscles and joints that like tell your brain what's going on. And we don't really know like how that signal gets processed. It all goes like a part of your brain in this like real this sulcus that's like confusing and deep, and we can't like really record from it because it's too deep. So we just like pretend like it doesn't exist. And I just love there's like a central area of our cortex that processes this like very vital information, and we like don't really know why or like what it's about.
Did you say the brain region?
It's like called like it doesn't even really have, it's like primary this proprioceptive cortex, but it's like not really we don't know what it is.
Some unnamed region.
Yeah, I know where it is. You can point it out.
Okay, one word, yes or no question. Do you think there's a risk that people outsource self-awareness to devices?
Yes.
Most overrated signal people obsess over?
Everything that your smartwatch tells you.
One book or movie that changed how you think about the brain. It doesn't have to be related to neuroscience.
Eternal Sunshine of the Spotless Mind.
Good one.
This is fun, actually.
If the future you're building through Constellation were a film, what would be its title?
We're not that worried about it.
Okay, coffee, supplements, or sleep. You only get one.
Sleep.
Nice.
Yeah. You'll die without sleep.
If you weren't building Constellation, what would you be doing instead?
Photojournalism.
Journalism?
Photojournalism.
Photojournalism. Brain health tip of the day?
Sleep.
Last one. If you could measure one thing about your brain, what would you measure?
The proprioceptive cortex.
All right. Thanks, Avery. 10-15 minutes of questions. We just passed the mic around.
So earlier you said state space, and so I'm very curious what technical components / techniques you're considering for building these foundation levels, and how you're planning to train them, for example. Like there are approaches that take choice behavioral data and kind of do more of a fine-tuning thing versus others who take more neuroimaging data. So like where are your primary data sources coming from and what are the first technical approaches that you're aiming to try?
Just coming at me like that as a stealth company. Okay. Yeah. I'm not gonna be lame. I'm gonna tell you guys things. We think that all of the signals matter, and we think that that's sort of like counterbalanced with like things that are accessible. So is it accessible to collect like a lot of functional MRI data? Like, no, it's expensive and you can't like move around in enough MRI, so you can't like do the things that normal people do. And so we're the kind of constant trade-off that we are really trying to get our hands around is how do we get as much useful information about people's brains, bodies, and environment without compromising their natural state capacity as possible. And so the data that we record is like the maximalist version of that.
So you're collecting your own data?
We are collecting our own data. We collect a lot of data. Yeah, it's delicious.
Okay, thank you again for the talk. So, as was mentioned earlier, there's been a lot of excitement with neurotech recently, a lot of consumer companies coming out and releasing products like Motive, Neurable, Elemind. And one thing we've observed, I suppose I've observed, is that a big barrier is the form factor, right? With BCIs, people wear wearable devices. They don't expand as much in the market because, who wants to walk around with a headband all day, or it's something that's like a big fixture on your head. And I wanted to ask you if there's a path forward, if you see a path forward in overcoming the form factor for neurotech devices.
Yeah, I like this question. I guess I don't really imagine a world where people are like afraid of looking dumb with the device, just because like those sentiments change. Like I've looked at the data, like the people being queried over like huge time scales around like norms around what they wear and like neurotech specifically, and it's like the trajectory is pretty clear. Like people are going to be okay with weird shit on their faces. Like I actually think that's like sort of like a not. It's like an overreaction. I feel in general. I think people will put weird stuff on their faces and bodies. I think there's an entire like industry though. I've probably met 10 founders whose whole deal is like making it pretty or cool or modular, and it's like external capacity as like a design choice. And so like if I'm wrong, like great, 10 founders are edging that. So I think we're gonna be good either way. I think maybe like what I'm more obsessed with though, and I'm more concerned about, is that as this problem resolves itself either through like form factor or through like societal acceptance, what is like definitely not keeping up is like people's preoccupation with the downsides of like the last like inner sanctum of your privacy just becoming like a platform to make money. I can say this because one of my advisors like founded that Ford company over there, but like, every time it's sort of like what happened with the sequencing companies. It's like people get really excited, they get sequenced, then 23andMe has like a big data breach, and now like insurance companies could like discriminate against you based off of like your genetic information. And I'm like, that's like small potatoes to like your private thoughts and beliefs. So I'm like a little bit concerned about what happens in like the consumer world where we like get better at decoding, but like nobody cares. That freaks me out.
Thank you.
Also, shameless plug to that question, you should check out our beta.
Hi. During the lockdown, I guess on the first day of the lockdown, I wanted to figure out what do I need to cope. And I bought a device that I actually first used in the 90s called the Casina Mind Machine. Are you familiar with it?
Not super, catching up.
Basically, it flashes, you put on goggles and it flashes colored lights in your eyes, put on headphones, and there's beats that match it. And it starts out at the frequency that is the same as, I guess, beta waves, breaking wavelengths, and then it begins to slow down. And apparently while you're at a beta wave state, your brain syncs up with the frequency, and then the brain waves slow down. And literally, I felt so chill during the lockdown. I felt guilty watching people, like the anxiety people have. And I'm just wondering, first of all, I was wondering if you've ever heard of it. If you haven't, check it out, it's great. And I thought, if you hadn't heard of it, it would be really cool to see if it's legit and if it's really slowing down your brain waves.
Okay, I do know, I didn't recognize the name. It's like a very rich storied science, consumer medicine, history of building things that try to train brains to certain frequencies or oscillations or whatever. And I think like, if you've ever been hypnotized, like hypnotism is a thing. You can be hypnotized. If you've ever meditated, you've been into an altered state through like, induction from tones or focus or whatever. Like you've like been in this altered, like there's many things that we know put people into altered states that have nothing to do with like drugs, for example. And I guess I know, I'm trying to think how much of this is public, I think almost all of it. There's like a company that's doing really great clinical trials of like flashing lights at people's retinas to like deal with like clearing like amyloid plaques or something for Alzheimer's. And I guess like I kind of alluded to at the beginning, there's so many inroads to like screwing with your brain that don't involve opening up your head and like flashing lights and stuff. Everybody has felt emotions watching a movie or listening to music. Like we are very influenceable from like the stimuli that come through our eyes and ears. And so I'm really glad you found this technology. It sounds like you won. That's awesome.
Yeah. Well, when I first tried it in the 90s, I actually took a first date to a salon that offered it, and it was like a cheat code.
Ask you what that means later.
Hi. So this is more of a personal intrigue question. So right now I'm a comp sci student, and I realize like building software is fun, but it also kind of in a way boring. Or I've been looking into what can you do with computer science, and I feel like I know some of the tech but zero of the neuroscience. So I've been wondering, like, from your past academics or what you've been working on, what are like good resources to get into it and also get an idea if it's something you're gonna like working on? And the second question is maybe to get yourself excited about the field, what is like a new trend or something that's been coming up that you're like, okay, this specific thing in the field is something people should look into to get excited about it?
That's a really good question. I'm sure Jelly also wants to answer that. Okay, just I want to clarify. The first part was like, what is like a good starter kit for neuroscience? Is that what it was? From the perspective of like a CS person?
Yeah.
Okay, well, I'm not a CS person going to neuroscience, but I was a cognitive scientist, so I can say there's like a really classic cognitive. I think cognitive science is your bridge because cognitive science involves like CS and philosophy and neurobiology. There's this guy named David Marr who is beloved. I'd read a David Marr book and you'll be all set. And how do you know if you're gonna like it? I think the greatest tragedy of our education system is that we force people to do things that don't at all prepare them or tell them how the next phase is going to be. I think becoming like a PhD is really funny, right? You like go to undergrad, which means you're like a consumer of science. You like read books about it and stuff. And you go to like a grad school where you like do grunt work for a year or learn more, and then like sort of slowly break your brain trying to produce things, and then you go be a faculty where like you're not doing that anymore. You're like managing people. And in no time did you like get prepared for the next stage adequately. So it's like sort of like a weird use of your time. So I can't answer that question about like how do you know if you're gonna like it, because even doing it will not prepare you for the next stage of that process. So that just sucks, I'm sorry. The best thing I can say is like find non-traditional ways in to like do the work, and so you can be exposed to it and keep your eyes open, like talk to people, see what it's like for yourself. Because I think like telling someone what it's like to be like a producer of science is like an impossibility. It is like both the most freeing and the most like horrific experience simultaneously at the same time. You're like butting up against the edge of what we know, and that's like cool and also void level terrifying. So I don't know, it's like how do you? It's about your own psychology. And then what was the last thing you said? It was
Like, what are new things coming up you want to look into that are exciting?
There's a bunch of people, especially big tech companies, that have been publishing how they like will just start dumping neural data into like transformer models, and you're like, why would they do that? Like, go read and try to figure out why they would do that. And I think that would be a really interesting way of like getting a hook in. I don't know if you want to say.
Thanks.
Of course.
Hello, my name is Evelyn, and I was in psychology before, like then cognitive science, and then breaking into tech right now. And I have a question for you. So like recently, me and my co-founder started this like thing. I can't really talk about it because it's like complicated still. But like we did a little pitching and stuff. Like there was a lot of feedbacks, a lot of setbacks and stuff. My question is just like, how do you deal with frustration? Like when people reject you, like on your pitch, just like when you believe in your stuff, like if you think it's great, and people are like, no, we didn't like it, like we don't see a vision in this project. How do you deal with the frustration of it, and like how do you like move forward? What are some informations that are good? I mean, what are some feedbacks you consider would be helpful, and what are just like noises? Like that's my question.
Congrats on
Thank
starting
you.
something that's really cool and hard. I'm happy to talk with you more offline, but just for the sake of everyone hearing, I think like this part, like pitching is, it doesn't matter how good you are at pitching or how cool your thing is, like trying to get people to buy into your complicated idea is like basically like a 95% no exercise, and that just is how it is. I've like, the people who have some secret way of making it not like that are like special and lying, and that's not how it actually is. When I was in grad school, I was hiding basically in a small room to like just focus on finishing my PhD, and someone else moved into that small room, much to my chagrin, and he did it because he was hiding because he was trying to build a company, and he didn't want like the university knew he was building a company, so he was getting paid while like built this company. And like in the last 6 months of my PhD, he pitched like every day, like in the cubicle next to me, otherwise like an empty room. And I like obviously hated him, but also it was a really cool experience for me because I like, before I had any conceptualization of wanting to start a company, I watched someone go through like, I would say the hardest part of starting a company, which was to like just get rejected like 1,000 times before someone like paid attention to him. And one time he came up to me, and I have like no idea how companies work, or like how pitching work. But he would like leave one of these pitches just like wrecked, like just you could tell he just like looked like he ran a marathon. He's like exhausted, seeming he's tired. He's like disappointed because it's clear for him to know. And they're like, "What are you doing?" You know, he's like, "Oh, I'm pitching." I'm like, "What is that?" And he kind of told me. I'm like, "Okay, well, like, how do you what's next?" And he's like, you know, does like his face white, and he's like smiling, excited again. He like is transformed. And he's like, "I do it again." And I was like, "You're crazy." First of all, but I think what I appreciated from that, and it like that really stuck out for me when I was doing when I had to do this slog or this pitching. It's just like it's a belief thing. Like it's a belief in yourself and the idea, and at the earliest stages, that's all that anybody else cares about too. Like they don't really care about your idea; they care about like, believing in you. And I will say that like a big inflection point in my life, in my business, and like my capacity to be a founder and CEO was when like a stranger who I met at a coffee shop who was reading a weird book that was like very relevant to my field. I started talking with him, and it turns out he had started a company that is very famous and got acquired very famously in the same space. And I was talking with him, and I gave him my pitch, and he was like, "That was trash." And I was like, "Whatever, my pitch is good, shut up." And he's like, "No, it's like you don't like, it's not, you don't have like that belief. Like you, even just being casual, you need to like, I don't believe it from you." And I was like, lame, I feel like I believe it. But then he spent like 6 hours working with me, and I thought about what he said, and there's a bunch of like kind of exercises in there. And that night, like something actually changed for me, like something clicked, and it was the best way I could distill that change was that like everything became a little bit more internally consistent, and I started believing my own narrative because it made more sense to me once I was able to draw the through lines and be internally consistent. It was like, instead of like having a puzzle where there's a couple pieces missing and I'm just like trying to kind of glaze over the parts that are a little patchy, it like was a picture that I was describing that was coherent for the first time. And I think the way to get there is to like talk it through with smart people a lot and stress test it until it like makes so much sense to you that like anybody else would be dumb to argue with you. And I think that's the point where people will start saying yes at a slightly higher rate than, you know, negative 1%. People, I don't know.
I think some people would go so far as to call brain waves, rhythms, oscillations, and a phenomenon. That doesn't resonate with me, but I'm not really sure, how to think about them. And curious how you do. What's the functional role of brain waves and oscillations?
I don't know. I think like it's a bunch of labels describing a bunch of aggregate activity, and like you can causally perturb people's states by fucking with the rhythms, and you can also do it. Like they do stuff, that's for sure. But like how much of it is an epiphenomenon versus how much of it is like a causal mechanism that's like something we evolved for. Like, oh my god, the people in my company is literally getting like arguments about this every day. I don't think there's an answer. What do I personally believe? Like I don't care. I think it's like, not like in a dismissive way. It's like I think like if something is functionally useful, then like I'm excited about it because I'm trying to like help people and do things in the world. And like I do remember a whole period of my life when I was like primarily a scientist, and I was asking this question as a scientist, and I cared more about like the why or whatever. And I found myself to be like extremely frustrated with this series of questions because it felt like it was like I almost said something that it felt like it was like an exercise for people in like intellectualism, not like a really valid science question, because people were like asking they were chasing down like weird retorts to things that people said in like the 70s or whatever. And I'm just like, why? This feels like a waste of taxpayer dollars. So I kind of think like there is a way to study this scientifically that would be more interesting, but I haven't really been impressed with people's attempts in the last couple of years. But I think they're functionally relevant, so.
Maybe do 2 more questions.
Hi, so first of all, thank you so much for the talk today. I learned a lot. I'm actually a recently graduated psychologist. I have a bit of an analytics background as well, so it was great to hear insights from both of you who are obviously in the field. Well, my question is actually about artificial intelligence. So I would like you to predict how influential you think AI is going to be on neurotech and related fields, especially in the coming 5 to 10 years. And if you see AI being a largely supportive force, how do you think AI would be ideally integrated into the work that you do? Thank you so much.
I'm just old enough to be like, there's still like a weird like burning sensation in my brain when people say AI, because what that was like a couple of years ago was like something totally different. But I'm growing up, I guess. I'm not as irritated about it anymore. I too say AI 100 times a day. I think like machine learning and the associated advances that have happened in the last couple of years are like, for better or for worse, like going to be the way that the obsession for the next 5 to 10 years in society and science and engineering broadly. Like I don't think that's escapable, because like things keep happening that like, if everybody has a prediction, if an entire field thinks that something is going to happen when you do like a bunch of experiments, and then like a different thing happens, that's like important. That means that everyone's wrong. When everyone's wrong, that means that everyone could be right about some weird other crazy thing. And so it's kind of esoteric, but what I'm really getting at is that like, when you throw a bunch of data at a problem and you feed it to a transformer, the transformer starts like doing weird emergent things, people's imaginations get the best of them. And I think that is going to carry us through like a very long period of like obsession with these techniques. And I think for neurotech specifically, I kind of alluded to it, but we actually really do need better methodologies for handling like giant, diverse, complicated, sparse, noisy, weird data sets. Like people have been trying to collect huge multimodal data sets for decades, but like they don't know what to do with the data. And I think like we're finally finding things to do with the data that are maybe useful. And I think like I'm not at all concerned that like some company somewhere is going to figure out how to like reliably write signal into the brain or not. Like there's people here who like mess with TMS and like, you know, you can write signal into brains non-invasively in pretty reliable ways. I think we're going to get better at doing this across many dimensions. Like I have no fear about the hardware part. I think we're going to be able to read increasingly well from brains in non-invasive ways. Like the invasive ways will get good and safe and blah, blah, blah. Like that's all like going to happen. Those are like solvable engineering problems. Like it's not going to be like that hard. But I think all the problems that are going to really be sticky are going to be like, what do we do with all of that signal once we have access to it? And that's like a machine. That's an AI problem. You know, and so I think it's here to stay. And there was one more last piece that I wanted to answer that I don't remember what it was. What was your last part of that question?
Right. I was asking you about how AI, in an ideal situation, would be most effectively integrated into the work that you do, for example, on a day-to-day basis.
Yeah, I hate how true this is, but like in my currently very small team, like we solve problems like on a weekly basis using LLMs that 3 years ago would have taken us months. And we do that pretty regularly. Like we pretty regularly produce a thing that helps us internally, like as a team, like in a stupidly short time scale, and like it just means we're moving it like 5 to 10 times faster than we would have without LLM. So we use them every day in every way you can imagine, but we make a lot of like internal tools using LLM, using like code support tools that just like, it's amazing, you know?
Last question.
Hello. So building a neurotech product is obviously extremely exciting because there's 100 million ways that you can take it. But on the same side of the coin, there's also 100 million blind apples. How do you choose what to work on?
When I was trying to decide what to do with my life, post PhD, post like working at a couple startups, I had this idea that I wanted to be this company, and I started pitching it to the big neurotech companies, one at a time. And by the end, I like pitched to like all of them. Basically, I like told everybody these ideas. So all those people now, they have all my secrets. And what kind of happened was that at first they were like, "Yeah, we're not that worried about it. This isn't that big a deal." And then like a couple of months in, like I started getting job offers to build this internally, but at like very disparate kinds of companies. And I think then that was when I decided to start this company. And I guess like the lesson learned to answer your question here is that I think like there's lots of generalized problems that have to be solved, like infrastructurally, platform problems, and like delivery. There's all these like other pieces, like the less sexy pieces in most cases that like have to get addressed that aren't just like, can I dump current into this brain somehow, or can I like extract electrical signals from this brain somehow? That like everybody's gonna have to solve once you've like abstracted away the like really weird nature of the problem. So I think like that is one answer, or one class answer, sort of like the support infrastructure, the tools, the platform components of all these things. And then the other piece is like, I'm a big sucker for like trying to get something non-invasive scaled. Like I think scaling something non-invasive is like a requisite step for this to take off. I think that there's really kooky ways to do that the only piece of like advice I would give to anybody thinking about like building, investing, like whatever in the space is that like, we don't know what most of these perturbations, like these stimulations, these drugs, whatever, we don't know what most of them do on most axes of like how to function, because we don't know. And the story, I studied history of science in college, I've been obsessed with this for the last 10 years, like the story, if you dig in, is always the same. When you start looking for other axes of effects, you find them. And I think like the holy grails are going to be stimulations and perturbations and whatever in neurotech that like have a really narrow band of effects, or that it's at least controllable in like closed loop. And I would say that like basically nobody is thinking about it that way, and that's like very weird to me, because when you make your cool device and it doesn't kill people, the next step is like, how does it help people? And then when we become increasingly accountable for understanding the ways it hurt us, everybody's shit's just gonna hurt us a lot. And so it's, I think that's like a very weird blind spot that people aren't thinking about. And I think thinking about that ahead of the curve is like gonna be like why you can be a generational company or whatever.
All right. Thank you guys for the questions. And thank you, Avery, for the awesome chat and the answers. And we'll both be around after this event. So if you guys want to hang out, there are probably more snacks over there. And yeah, we can keep the conversation going. Thank you guys for coming. Hopefully there will be more, so watch out for the results.
Yeah.